Now we're in Sketchpad and we're going to be looking at the types of angles, or the beginning types of angles that occur within the circles. The first one that we're going to talk about is a central angle. Central angle is an angle that's formed by two radii and the vertex is at the center of the circle. So what you can see that I did, I have this circle here and there's my two radii. Okay? These two radii, this angle here, this central angle, intercepts the arc. Now what that means is that the endpoints of the angle, so the endpoints of the radii, are on the circle. Between those two endpoints of the radii, you create this arc. Okay? That's what we call the intercepted arc. Now there's a relationship between the angle measure of the central angle and the arc angle of the circle. Now I say arc angle because we will be talking about arc length in the next coming sections. So let me go ahead and measure this angle, this central angle. So measure this angle. Okay, we see that's 95.71 degrees. And now I'm going to measure my arc, okay, the intercepted arc. So I'm going to measure the arc angle. What do you notice? They're the same. And watch, if as I move my endpoint of my radii, you can see that the central angle is always the same degree measure as the arc, and vice versa. So even if I go like this, oh no, okay, we want to stay under 180 degrees. Sketchpad always measures the acute angle, so we want to look at that acute angle. Okay, so the central angle is the same degree measure as the intercepted arc. Now, there's another type of angle. That type of angle is called the inscribed angle. Okay? An inscribed angle is an angle that is formed by two chords whose vertex is on the circle. So I'm going to still use my same intercepted arc, but now I'm going to start at A and make a chord. And remember, a chord is a segment whose both endpoints lie on the circle. Okay? Now, since I want to create what we call this inscribed angle, I'm actually going to have those two chords intersect at a point on the circle. Okay, so let's name this point. Let's call that point E. So the two chords intersected at point E, creating what we call this inscribed angle. Now, if I hide my radii, so they're not in the way, you can see what an inscribed angle looks like. Just the two chords, and it also intercepts an arc. So if you trace out the angle, you would see that it still has endpoints A and C on the circle. That creates an intercepted arc. Now, we already know that this arc is 103.27 degrees. Let's measure this inscribed angle. See how many degree measures, how many degrees it is. 51.64. So that might be kind of hard to see the relationship. Let me move some of the. Oh, could you see there? What's the relationship between the arc and the angle measure? Hopefully you're seeing that the angle is half of the arc. So what I can do is, let's bring up our calculator, right? If I take the arc and I divide it by 2, we should get the angle measure. Okay, let's see what happens. So you can compare those two angle measures there. You can see that they're always the same. And notice this was still my measure of my central angle up here, right? So this measure of my central angle is also staying the same measure as my arc. Okay, so central same. Get it in your brain that the central angle is the same. Okay, central angle is the same degree measure as the intercepted arc. Inscribed angle is half of the measure of the intercepted arc.